In the next exercise, we're going to be matching a table to a graph. Now the table, just like a graph, is going to have an independent variable. In this case, it's still time, which would go on the x-axis, and a dependent variable, which is still distance, which, as you've seen on the previous graphs, goes here on the y-axis. Now, when we're analyzing one of these distance times tables to match it to a distance time graph, we're going to be looking in changes. The first thing we're going to do is make sure, is this going by the same amount of time every time? And it's always 1 second, so this is a good table for this. So I know that I'm starting at 0, 0, so I'm going to find my starting place, which is here, 0 seconds and 0 units of distance. Now I look at my first pair of changes, and I can see that it's going from 0 distance units to 40 distance units, which means that it is moving away from the start. So I'm going to say, oh, there's a solid line representing that change, because the distance is increasing. For the next change, we can see that it goes no additional distance, so we start to see a flat line. So there's no speed, and that distance isn't changing. And it stays that way for 3 seconds. 1, 2, 3. Then we see a change of going from 40 distance units to 20 distance units. And that's not happening as fast as this one. So it's going to be going back towards the start, but it's also going to be less steep. Okay? And then it'll be off the graph from the way I've drawn it, but this is going to go all the way back down to 0 at the end. Now notice it's going from 0 to 40 in 1 second, which is quite fast. But when it goes back, it's going 40, 20, 0, which is half the speed. So since this is faster, this is going to be a steeper line. And since it's slower going back, it's going to be a less steep line headed back. Now, a flat line in these distance time graphs means that there's no motion happening.